So could chemical evolution have occurred in water?
Well, in fact, water is the last place I'd want to try to build up the big molecules from the little ones. Because, for instance, when two of the amino acids form, it's called a peptide bond, and the protein is just a continuation of that. See, every time they form that bond, they kick out a water molecule. So the process is called condensation, and it's polymerization because they're making many different things as a polymer. Okay, so condensation. But the thing is, you don't want water there, because if there's water around, the water would pop back and actually break up that bond. So it would go in reverse. It's called hydrolysis, which means breaking up stuff using water. So hydrolysis would be what would happen if you have water in the reaction. And the thing is, when you try to make a protein or a nucleic acid, a synthetic chemist will not do it in water. And in fact, what he would often do is add a water removing chemical. They call them condensing agents to pull the water off, you see. But the primordial soup didn't have those. And even a condensing agent would not last well in the ocean, because the whole point is to react with water, so it's not going to last very long in the ocean. So, in fact, a little anecdote here, giving some creation talk. I think it might have been university, and a guy introduced himself to me in the break about how he's actually a protein chemist, a synthetic chemist who makes these big things. And so during the question time, I actually asked him personally, I mean, would you ever use water in your reaction mixture? And he sort of, of course, in those sort of things, I don't ask a question unless I know the answer. Okay, and he sort of said, "Are you kidding me?" Well, that's the whole point. Yes, that's the whole point. I was kidding him. That water is a ridiculous place to do any sort of condensation reactions.